Now we're going to learn about the Hardy-Weinberg equilibrium equation. To start, we have to learn more about what evolution is. Evolution is the development of new species from older ones and the minor changes within a species from generation to generation over long periods of time that can result in the gradual transition to new species. The scientists now generally define evolution as being the sum total of the genetically inherited changes in the individuals who are the members of the population's gene pool. This definition of evolution was developed largely as a result of the independent work in the early 20th century by Godfrey Hardy, an English mathematician, and Wilhelm Weinberg, a German physician. Through mathematical modeling and based on probability, they concluded in 1908 that gene pool frequencies are inherently stable, but that evolution should be expected in all populations virtually all of the time. The equilibrium equation is what they developed to simplify this process. It can be used to discover the probable genetic genotype frequencies in the population and to track the changes from one generation to another. This equation is p squared plus 2pq plus q squared equals 1. P is the frequency of the dominant allele. All of the alleles in individuals who are homozygous dominant, for example, capital AA, and half the alleles in populations who are heterozygous, which is one capital A and one lowercase a. Q is the frequency of the recessive allele. All individuals who are homozygous recessive, which is little a, and half the individuals who are heterozygous, which is capital A, little a. Because there are only two alleles, the frequencies of one plus the frequency of the other must equal 100%. This means P plus Q equals 1, Q equals 1 minus P, and P equals 1 minus Q. Hardy and Weinberg realized that the chances of all possible combinations of alleles occurring randomly is P plus Q squared equals 1. Now this is the same as P squared plus 2pq plus Q squared equals 1. P squared now is the predicted frequency of homozygous dominant people in a population. 2pq is the predicted frequency of the heterozygous people. And finally, Q squared is the predicted frequency of homozygous recessive people. Now for an example, so we can see how it actually looks like. A population of cats can either be black or white. The black allele has complete dominance over the white allele. Given a population of 1,000 cats with 840 black and 160 white, determine the allele frequency, the frequency of individuals per genotype, and the number of individuals per genotype. This problem is asking for 3 parts. First, to determine the allele frequency, then the frequency for individuals per genotype, and then the number of individuals per genotype. To do this, first we have to find the frequency of the white cats, the homozygous recessive genotype, since they only have one genotype, BB, and it's simpler to solve. To do this, we need to do individuals divided by the total population. In this case, it's 160 divided by 1,000, which equals 0.16. Now that we know this, we can put that Q squared equals 0.16. Now the square root of 0.16 equals 0.4, so it stands to reason that Q equals 0.4. Now, using the Hardy-Weinberg equation P plus Q equals 1, we can solve for P. So P plus 0.4 equals 1. So in that case, P has to equal 0.6. Since we now know both P and Q, we can solve for the remaining frequencies using P squared plus 2PQ plus Q squared. So P equals 0.6, so P squared equals 0.36. 2PQ equals 2 times 0.6 times 0.4, which equals 0.48. Now again, looking at this problem, we've now determined the first two parts. In that case, it's that the dominant alleles are 0.6, recessive is 0.4, individuals with dominant is 0.36, individuals with heterozygous genotype is 0.48, and individuals with the recessive genotype is 0.16. Now to solve for the number per individuals, we have to do the frequency times the population. As we can see, we have to do the frequency of the dominant, 0.36, times 1,000, which equals 360 black cats. For heterozygous, we have to do 0.48 times 1,000, which is 480 black cats. And finally, for the recessive, we have to do 0.16 times 1,000, which is 160. Hopefully now you understand more about the Hardy-Weinberg frequency. Thanks for watching.